Hi there, I'm Hodgson. I'm the co-founder of Amber Video, and I'm here to talk to you about why we need to find a durable approach to preserving trust in video and how we can go about doing that. Now, I hope that you have your startup buzzword bingo cards ready because we're going to be talking about generative adversarial neural networks, about neural rendering pipelines, about society, and about blockchain. Let's do this. So Amber Video is a startup with the goal to create a truth layer for video. And you'll see exactly what we mean by that in this talk. So I'm an engineer. Academically, my background is in artificial intelligence, but I started my professional career in video, and that's kind of where I've been ever since. I've worked on a number of research-focused projects, predominantly at the intersection of AI, video, and security, both in industry and also in startups. Now, I first encountered some of the technology I'm about to talk to you about kind of by chance back in 2016. And this was before we'd even seen any deepfakes posted onto YouTube or onto Reddit. But it's kind of become a bit of a passion ever since then. Dare I say, an obsession. And that's not just because it's a fascinating area of work, but also because of the lasting implications it could have on society. Just this year, we saw the impact that video evidence had on making us all face the grim realities of systemic racism in the US and around the world. And so an important question to ask is, would the video evidence of the killing of Eric Garner, of Michael Brown, of George Floyd, could these have been catalysts for change in an age of... So to tackle this question, first I think it's important to be clear on what are deepfakes. Now I'm sure many of you have seen some of the fake videos that have been circulating around the internet and shared on social media, and so none of this will be particularly new. But let me introduce a few terms so we have something of a common language. So there are many ways to create fake videos. Some of these ways use AI, and a further smaller subset use deep neural networks. Typically, not always, but typically, when we talk about deepfakes, we're referring to deep neural networks applied on people's faces. And there are actually two main approaches to deepfakes. One is replacement, where you're swapping someone's face for someone else, like, for example, swapping Jennifer Lawrence's face for Steve Buscemi's. And another that is reenactment. And that's where you're synthesizing new content, exploiting someone's likeness, such as Jordan Peele's impersonation of President Barack Obama. Now, of course, deepfakes are not the only type of fake video. A few honorable mentions go to some other type of fakery, which have now retrospectively been coined as the slightly nonsensical term shallow fakes. But here are some of the examples. So in-painting or copy moves, and that's kind of the more traditional alterations that have been used in Hollywood for decades. The idea of adding or removing objects from a scene using special effects. Another one is altering playback speed. Now, famously, we've seen a video of the Majority House Speaker Nancy Pelosi where the playback speed was allegedly altered and her voice pitch corrected to make her sound like she was slurring her words. And we've also seen instances of frames being removed. For example, the video of the journalist Jim Acosta in a press briefing where he appears to be forcibly swatting away the hand of a White House aide. Deeper analysis seems to indicate that some frames had been removed to make it appear as though his hand was moving faster than it actually was. So why are deepfakes and shallow fakes a problem now? Well, first I think it's worth highlighting that deepfakes are not universally bad. There can be positive applications for this type of technology, such as for humorous purposes, for example. Just recently, I noticed the creators of South Park have started a new show using deepfakes to create amusing sketches. Here, this screenshot is the comedian Bill Hader doing a great impersonation of Arnold Schwarzenegger, and someone swapped in Arnold Schwarzenegger's face, and it's a really amusing video to watch. It could also be used, for example, in filmmaking. And now we've seen recent work such as bringing Peter Cushing back to life in the Star Wars films. Now that in and of itself was not a deep fake, but we can imagine this type of technology being able to be used by creative individuals to produce really amazing and interesting videos and films and TV series. Another application could be internationalization and accessibility. We could imagine deepfakes being used, for example, to improve the appearance of dubbed films and TV shows, where deepfake technology can be used to better model the lip movements of the actors when they're being dubbed over, so that the lip movements more closely match the dialogue in that foreign language. But of course, it can also be used for malicious purposes. And I like to split the malicious purposes into two broad categories: impersonation and the falsification of evidence. So impersonation is probably the best known one. This is the idea that someone's likeness can be faked. We can imagine a video of a politician saying something that they didn't say, and that being used for political purposes, being spread across the internet, going viral, and having some sort of political objective. Another example is we can picture a video of a CEO of a company saying something hugely objectionable, and then we discover afterwards that, of course, they didn't say that. It was a competitor that created this deep fake of the CEO, and of course that severely impacted their reputation with their clients and maybe their stock market value. But then there's also this other malicious application of deepfakes, this idea that actually not all deepfakes will be necessarily spread virally, and some may never become public. We can imagine an attacker blackmailing or ransoming someone by creating a deepfake of them saying or doing something really bad. We could also imagine an attacker using a deepfake to change the outcome of the justice system. For example, by replacing someone's face in some CCTV camera footage or some police body-worn camera footage. And then there's also kind of associated with that this idea, this problem that just the mere existence of deepfakes could cast doubt on video remaining a reliable source of evidence. And that could lead to otherwise perfectly good evidence being ignored or dismissed as potentially tampered with. Finally, there's also this idea that fake video may actually erode the value and the power of citizen journalism, and we've seen the importance of this tool in triggering important conversations just this year. So there are really three main trends we need to consider when we're evaluating these risks. The first one is that deepfakes are just getting cheaper and easier to make and increasing in quality. So really it's a better investment for a better return on investment for any potential attacker. There's also the issue that there's increased automation. I mean, we know now that maybe one person may be able to create one convincing deepfake if they spend enough time on it and enough investment on it. But very soon, one person will be able to create hundreds of deepfakes at scale, each one customized to its particular audience. And then we also know that tools like social media will allow distribution of deepfakes at an absolutely huge scale. Not only that, but also the micro-targeting of those audiences, including leveraging things like news feeds and bots to push the virality of these deepfakes on these social media networks. So what can we do about it? Well, really there's two ways that we can address the threat of deepfakes. One is to actually detect when an alteration has taken place, and the other is to authenticate videos from source. So looking at that first approach, detection, there's a number of different tools that we could use, different approaches, but Overall, what we know is that deepfakes are generating new content. So what we can do is use some forensic approaches to try and detect some of the patterns, some of the artifacts that are being left behind by the algorithms, the deepfake algorithms. So one of the first things we tried was to take an off-the-shelf classifier, ResNet, a classifying neural network. It's already trained to be able to say, oh, this is a picture of a person, this is a picture of a car, this is a picture of an apple. But we then trained it one step further by giving it pictures of faces that had been unaltered, as well as pictures of faces that had been generated or faked using some of the deepfakes tools that we came across. So we tell it, okay, this is a genuine face, this is a fake face, and get it to learn through that. And we found we had very good results in the lab, higher than 99% when testing it on new footage that it hadn't seen before. But of course, we had trained it and tested it on the raw output of some of these deepfake algorithms. When we tested it against some of the videos that were shared on YouTube and that had been spread through social media, well, we found that a lot of these had been created with quite a lot of post-production adjustment, quite a lot of manual control. And so the algorithm actually stopped being quite as accurate. In the end, we decided to go in different directions and take different approaches, but I know that others have continued working in this field. So I would point you to Face Forensics++, where they've obtained some really impressive results that outperform a human classifier. Another approach we can take is this more general idea of detecting any splicing of imagery into a video. And there's a few different ways we can do that. We can look at the data itself, looking at things like DCT coefficients or JPEG artifacts and the pixel values themselves. We can also try and build some models around the individual cameras being used to record the video. So modeling some of the sensor noise of the camera, modeling lens aberration or color filter array, and then trying to identify inconsistencies in those. We can also take an approach at looking specifically at some of the weaknesses in the most popular deepfake creation algorithms. So we can do things like try and identify inconsistent head poses, identifying inconsistencies in blink rate, or also looking at some of the post-processing technologies that are applied in these algorithms, such as hue matching or the blurring of the edge of the face, and trying to detect some of the blur functions that are being applied there. But overall, it feels like it's a little bit of a losing battle trying to detect deepfakes. And that's because we can imagine that the best deepfakes will have a lot of post-processing, post-production work applied manually, which is not necessarily going to be picked up by some of these detection algorithms. We also have the added challenges that once these videos are being uploaded and shared and reshared, they're going to be transcoded over and over and over. And some of the patterns that we're relying on in these detection algorithms will simply disappear. But perhaps the most important limitation is that at the end of the day, it is kind of like an arms race. Every time a new detection algorithm comes out, that can be used as input into the error function of the next generative function. So because of the way that these deepfakes are working, that they're generative adversarial neural networks, they are by design using neural networks as a way to assess their own quality. And so any algorithm used to detect can be used as a scoring function for this algorithm to learn and to evolve and to ultimately defeat it. So this takes me to what we see as the only real durable approach to tackling fake video. This idea of authenticating video from source, creating a trust layer. We like to think of it as creating something like TLS but for video. So how can we authenticate video? Well, we already know how to authenticate documents. There's been this idea for a very long time that you can hash documents and store those hashes somewhere secure. For example, now we may want to store these hashes in something like a public blockchain, with the idea that a consumer of this document would download a document from wherever they may need to download it from, and then validate its authenticity by hashing it on their own machine and then comparing those hashes to the hashes stored on the blockchain. Now, the problem with this approach is that document hashing isn't really compatible with the nature of video. For example, if we have a 5-hour long piece of body-worn camera footage and just 2 minutes of that is used in a video with maybe some logos pre-appended to it, some additional cutaways to other content, then the hashing of that final edited file is going to be completely different from the original. So what we did is we had a look at hashing each individual block of data instead, each individual audio packet, and then arranging these hashes in a tree-like structure. You might be familiar with these kind of trees of hashes or hashes of hashes if you've looked into things like Merkle trees and some of the technologies behind blockchains. The idea with these is that if one of the hashes change, you get an error propagating to the top of the tree. But the rest of the tree is unchanged, so you know where the error was and that the rest of the data was unaltered. Now, this approach works quite well if you're mutating data, but when we're talking about video and video editing, we're generally talking about content being spliced, content being appended, inserted, and so on. So if you imagine here the bottom left of this tree being the hash of a GOP that's being removed, then the problem is that the entire tree gets realigned and gets invalidated. So the inventive step that we came up with to address this problem was the idea of using the hash values themselves as boundaries for building this tree. What we would do is apply a modulo function on the hash values. So say, for example, applying modulo 6 would give us a result of 0 on average every 6 frames. The idea being that, we would make a hash of hashes based on the boundaries defined by the output of this function. And this still gives us a tree-like hierarchy of hashes of hashes, but that are invariant to prepending, invariant to trimming, postpending, insertion, and so on. So how does that look in practice? Well, we can imagine news organization attending a speech, filming that speech, recording content on the camera. The camera is hashing the video in real time, signing the hashes as they go along and storing them somewhere like a trusted database or on a blockchain smart contract. Then the news organization comes back to the editing desk, they edit their recording, trim or add content, but still maintaining a reference to the original hashes as sort of a metadata value in the media file. And then when they publish it to any particular platform, then the consumer can watch the video, retrieve the hashes, validate the signature, and rehash the content to ensure that the content they're watching matches the original signatures and that the content they're watching is authentic. Now, we actually built a recording app, an editing app, and a playback app that does just this. So here's the playback in action. We took a deepfake that was created by Jordan Peele in collaboration with BuzzFeed, where we actually took the fake and spliced it into the original that this was based off of. And the goal here in building this sort of platform was not to be the next YouTube or the next Twitch or anything like that, but really to show how this type of technology can work, to demonstrate how it can work in practice. But of course, this would need to be taken and integrated into existing multimedia platforms directly. So really, authentication is the durable solution to deepfakes and to digital integrity as a whole. It's not something that I think we would need to see on all videos across all platforms, but certainly at least for the videos of criticality, the ones that are important in the various contexts I presented earlier in the talk, for these potential misuses of video. So here are the 3 things I'd like to leave you with. The first is really a question, which is, how do we integrate some of the detection tech into existing multimedia systems, into VOD systems, into social media platforms, and so on? So I know I said authentication is the durable solution to this, but I do still think that detection has a role to play in some of these systems. The other question is, how can we efficiently and effectively build a system for platforms to share knowledge about the deepfakes that they've encountered in a secure and accurate way and in real time, so that they can try and prevent some of these videos spreading virally? And finally, how can we define a common framework for building durable authentication of video? Now, you've heard our approach and how it can be used to tackle some of the urgent use cases I presented, but I know that this is just the start, and I'd very much welcome your feedback. Thank you very much.